based on your you can say interests, based on your courses, the type of courses that you like, and based on your future plans, you might be interested in taking the CX, or you might not be interested. So that is just the idea of this presentation. Okay, so this CX is hosted by the mathematics department, and these are the objectives of this CX. Basically, after taking the CX, you will be a practical data scientist. You will be able to analyze the data. You should be able to generate the needed information from the data, and you should be able to work on some real case studies, some real problems. Okay, so data science is all about these 5 steps, and it starts with the data. Data is the raw material, and it ends with the information. Okay, so let me just start the pen app. I think I need to start it here. Just give me one second. I need to start an app. Just let me just stop the screen share in a minute. I'll come back in a couple of seconds, actually. All about how you have the data, and you take the data and somehow convert it to some sort of information. So that's the process of data science, from data to information. In between, you have many things to do. So in between, you have many things that you have to do. Usually, it involves some sort of understanding of the data, some sort of preparation of the data. Then you actually do the analysis. Then you do some sort of interpretation and also validation. And all these things, when you do it in a synchronized way, then from data, what you get is the information. Okay, that is what the data science is about. So through this concentration, you should be able to actually work on the real data science problems. Okay. Now, whenever people talk about data science or machine learning, actually data science and machine learning have a lot in common. So they usually think in extreme directions. Okay. For example, they think that either you have to have very good programming. Okay. Either you need to be an extreme side a good programmer, or on extreme side a good statistician, somebody who is good with statistics. Okay. But it is not the case. For industrial engineers, especially the guys who like operations research, you will find that there is a lot of optimization going on in data science. Lots of optimization going on in data science. So if you are those guys who enjoy optimization, then maybe data science is such concentration for you. Actually, in the data science concentration, as is the courses that we have here, they will not go deep in optimization, but you will find, okay, you will find how optimizations is used behind in those methods, and then maybe you can develop the methods with the different style or with a different method of optimization. So there is a lot of optimization going on in data science. Now, let us look at the courses that they have in the data science concentration. These are the 4 courses. One of the courses is from our department, and the other 3 are from the different departments. And these are different courses that you have: Math 405, Stat 413, ICS 474, and ISC 487. Let us start with the first course, Math 405, Learning from Data. This course, the learning from data, is very similar. I would not say like, the same, but I would say very similar to the course ISE 291. Okay. In fact, the idea of this course was that many of you, can you hear me? I'm not getting any response. Can you hear me, guys?
Yes, yes, Doctor.
Yes, Doctor. Clear.
Okay, it's okay. So the idea of this 405 is that there will be many students who will not be taking this ISC 291 course. So most of you guys have not taken ISC 291, right? Most of you might have, were in sophomore or above when these courses were introduced. So most of you must have taken ICS 103. Is it true?
Yes, yes.
Yes.
Okay, so those guys will not be taking ISC 291. So for those students, just to create a step to know what is data science, they have this course, Learning from Data. Okay, learning from data. Many topics, okay, from data science are here. But of course, because it's a 4-level course, slightly we can say at upper level, but you have many topics from here, okay. Now, what is this course going to teach you? It's going to teach you some basics of data science, okay. It has little bit of mathematics, okay, and then little bit of applied type of algebra that is used for, again, data science, okay. Then you have some probability and stats, okay, and then the concept of hypothesis testing. And for ISC, I think for those students who have taken 205 and 319, these topics are well known for those students, right? Then we have this one, which is based on optimization. And if you have taken ISC 321, you will know the convexity thing, okay? In ISC 321, you have nonlinear programming where we talk about convexity. And then we have the linear programming. So from ISC 3, you'll see some things, okay? So there is some optimization going on, okay? There is some optimization going on. And through this, they are trying to show you how you can solve this problem of least square minimization or least square error estimation. So the moment you see least square, it means you're trying to minimize something. The moment you see maximize or maximum likelihood, it means you're trying to maximize something. So they are like inherent optimization problems that you will be working on. Okay, then you have the gradient descent method. Again, in ISC 321 in nonlinear programming, we teach this. Sometimes if you have time, we teach the gradient descent methods. Then you have the matrix completion and linear regression. Actually, linear regression is the least square estimation in a way is the same thing, okay, linear regression. So these are all regression methods. Then you have the classification problem where you have neural networks, artificial neural networks. So again, it involves a mathematical model. It's a matrix multiplications, and there you use the chain rule, which is nothing but like gradient descent, but some sort of repeated differentiation, chain rule based on differentiation to implement a gradient descent method in neural networks. So that's all what we have in this course, Math 504. And you can see that there are many things that are coming from optimization from our 321 and 303 courses, and then it showed at an applied level to the problem of regression and classification. So we are discussing regression and classification, two problems here. Okay, that is your Math 405. And I believe, I'm not, I think for sure that they will be using Python to cover with these topics. Okay. So if you guys are coming from ICS 103 background, then there will be some learning of Python software that you should do it at your own time or at your own pace. Okay. So that is your Math 405 course. The next one is your Statistical Modeling course. It's offered by the Stat department. This course is focusing on the statistics in specific, but overall it is focusing on, again, the two problems, which are what? Regression and classification. Okay, so the regression and classification is a big area by itself. You have many things in there. Okay, You have regression here and classification here. So this course is focusing on these two problems, but then it goes more towards the statistical concepts of regression and classification. It has the simple and multiple linear regression. This is something that you must have seen in your course 315, I believe. Okay, and then that's what all you will see in this ISC 315. But now you have the concept of model selection and regularization. And here we will learn how in linear regression, when not all the variables are perfect, not all the input and output is perfect, in the data, then how you can come up with a better model and how you can use the concept of regularization. So that is something that you will be seeing. And then you will see an extension of linear regression, which is nonlinear. Okay, this is like an extension. So everything about linear regression, that's our first main topic of this course. The second main topic of this course is classification. Okay, classification is altogether different paradigm. Here you will have the output, which will be either which will be integers, usually 0, 1, usually some sort of classes. Okay, once you are done with the classification and regression, then you have the concept of GLM, generalized linear models, and then you have generalized linear mixed models. So these are like advanced techniques that you have for regression and classification. In general, you can use these models. Okay, so you'll have these advanced techniques that enhance the solution method for these two. So that is your statistical modeling course. Now you have, yes, Amar.
Doctor, I want to ask you about the classification. Is it the same with which we will take it in 291 IC, or is it different?
It is the classification problem is the same, but it has lots of depth. It has many variations. In ICS 291, we are looking at basics. So we are looking at simple classification from decision trees and classification that we can have from naive Bayes classifier. Okay, Bayesian, but naive Bayes classifier, and that's it. But then there's a lot in classification that we are not looking in 291. And you have here a lot of things in depth. I know this is at the 4 level, so you'll have a bit deeper concepts of classification. And you can see here, the entire course, roughly, entire course is all about regression and classification. That's it. Okay, these are the supervised learning methods. And you will see that in 291, if you are taking 291, you'll see that regression and classification are just 2 chapters. So in 291, you have more topics, less depth. Here you have less topics, but the depth will be high, that it will be deeper. Did I answer your question, Ammar?
Yes, thank you, Doctor.
Now we have one of this course from our department, Predictive Analytics Techniques. This chapter is all about time series analysis. To be precise, let me write it here. This chapter is all about time series analysis. Okay, so how is it different from the regression in general? Well, in regression you have data. Okay, for example, you have y, which is you need to find, and you have x1, x2, x3, x4, all these inputs. And then when you try to find y using x1, x2, x3, x4, it is more like regression. Now in time series analysis, what you have is you have x1. Let me use different notation. So you have old value. Okay, let's say old value on the first day. Then you have the value on the second day. Then you have value on the third day. Then you have value on the fourth day. So on. You have value on the 10th day. And now you would like to know what will be the value on the 11th day. So you have history of data, and you like to predict what is going to be the next value. And you must have seen something similar in forecasting chapter of ISC 402. So that is the forecasting part where you will see an overlap. But then in ISC 402, you see some basic forecasting like moving average, like exponential smoothing, double exponential smoothing, and maybe Box and Jenkins model, maybe. But here, no, we're going to go in deep, very depth actually, of all these methods. You're going to see in general. Again, there's a small overlap, regression analysis, small overlap, just because regression also does, some sort of prediction, right? Given x1, x2, x3, x4, find y. So it does some sort of prediction. But then you move to the time series analysis. You'll do exponential smoothing. Then you have ARIMA models. Okay, these are like the advanced version of moving average and autoregressive models. Okay, so ARIMA models, and then you have some more advanced method like SARIMA, like some methods that involve ARIMA with seasonality and so on and so forth. So in this entire course is all about how to analyze time series, Okay. Right. So now to the last course of this concentration. This is big data analytics. Now, all the things that you have learned in the previous 3 courses, you can apply them on your computer without much, issues. But when the data gets too huge, for example, you have gigabytes of data, okay? Too huge data coming from lots of multimedia, like videos, like you have surveillance cameras that generates lots of videos, and you have like brain imaging, the images of the brain that are taken for some operation or some test, maybe MRIs. So these are a huge sets of data, gigabytes of data actually, and or beyond. And these data, when you take it in your computer, just loading the data will consume your RAM. Okay, you cannot even sometimes open the files in your system because of so huge values of the file size. It will be running out of your memory, running out of your CPU power. Then how to handle such big data? Well, to handle such big data, you have to think in terms of how you can work on multiple systems, on multiple clusters. You divide the task into different systems, then the different systems together work on this big task. So that is what is the difficulty, and that is what is being taught in this course. So all the previous courses, it's just teaching you the methodology. When the data is normal, when you can just plug in the data on your computer and work with it, it will work perfectly. But the moment, for example, if I give you 5 numbers, can you tell me the average of 5 numbers? Yes or no? What do you think?
Yes.
Yeah. If I give you, let's say, 1,000 numbers, can you tell me the average? Yes, maybe you can just copy paste those numbers in your computer and then you can get the average. But if I give you a very huge number, okay, some 1 millions or 1 trillions of numbers, and then I ask you average, then calculating average will be a difficult task. Maybe you'll run out of the RAM for that big numbers, for that big amount of numbers. So you see, having more data will bring its own challenges, will bring its own problems. Okay, and that is what is being dealt in this chapter. Okay, first you are going to give some basics of big data. Okay, and then it tells you from which sources or where typically you find big data. Okay, and then you have some cloud computing, which is, I'm not sure why. Again, the course designer, I'm not the course designer, by the way. I'm not the course expertise in this area. So you have some topics, but here the big data actual mechanics starts, the Hadoop and the Spark. Okay, so Hadoop and Spark are different frameworks, different, you can say, mechanisms, roughly speaking, different mechanisms through which you can divide the data into different clusters, work on them, different computers or clusters work on them, and then get back the relevant answer. Okay, so that's the Hadoop and Spark, the very popular one and well-known one. frameworks that is being taught here. And then in general, you have for the usual data, you have RDBEMS, relational database management systems. So for big data, you will have something similar. So it just shows you how when you have big data, you can come up with the database management systems. Okay. And once you are familiar with the mechanism of how you divide and work, let us say, or how you work on multiple clusters, and then how the database can be created, then you will see how the machine learning or data science, actually data science and machine learning, there's a big overlap, maybe minor things here and there. Okay, from which side you look at it, also there's a small difference. Yeah, but again, people can, either way, they can also argue that they are different. You can find people that argue that they are very similar. So I will not go into that discussion, but here you will see how you can apply the machine learning or data science on big data. Okay, so all the methods that you learned before, for example, here linear regression, neural networks, how you can apply it on the big data, how we can apply the previous methods on the big data. And then you have visualization, and in data science, usually in this course you should have some visualization, but it is not stated here. But in ISC 291 you will see it. So maybe here they are not doing the visualization, but maybe they believe maybe it's very common, maybe it's obvious. But data science usually involves an important pillar, which is visualization, which is to draw plots, draw graphs, and visualize the data. So for typical data, you can do it in Excel. The data is slightly higher, maybe you need a better software. But when the data is big, you need some special mechanisms to visualize the data. And then some of the applications here you see which involves the big data. And then you have a very specific application. So you have some general applications, some new current applications, and then the application of security. This is one of the application. And then here you have some concluding information about big data, society, some sort of ethical, legal, and privacy related aspects. So these are the 4 courses that you will be taking in this CX. And this CX will be interesting for those guys who like programming. That's a must. Programming is the key. And if you are also if you are also the person who likes OR, then you might enjoy the methods, the depth of the methods, and it will be an interesting topic for you. Now, what about how it will be useful for you guys in future? Well, you have to think in 2 directions. Are you going for higher studies or are you going for workplace? For the guys for higher studies, and especially if you want to do research in machine learning or data science, for sure, these topics will be useful. That is the thing. And if you want to do higher studies where your focus is on machine learning, then definitely you will find many courses from here giving you good knowledge. Now, if you're going to the job, well, going to the job market, CX usually adds, I will say like a line, but it might add more than a line to your CV. Okay. The other thing is, these days, if you see the number of jobs in this area of machine learning and data science is quite high compared to the jobs in the traditional areas like quality and these. No doubt, I'm not saying one is better than the other, no. But what I'm saying is, because this data science and machine learning are jumping, artificial intelligence, these topics are right now at the boom. They are boom for the last couple of years, but it's still part of the boom. So there will be huge job opportunities in this area. There is one thing to remember, that data science, when people say data science, there are many things going on in their mind. Somebody can think data science is pure statistics. Somebody can think data science is pure programming. And then you have all those in between, statistics and pure mathematics and pure programming. Okay. So many a times when people think about data science, they think of degrees in mathematics or computer science. But for industrial engineers, because industrial engineers always have this difficulty that they have to create their identity. Always remember, for industrial engineers, not only for the data science, for anything, okay, you have to create your identity, because industrial engineering is not that well known to others. Industrial engineers know what industrial engineers can do, but somebody who's outside industrial engineering hardly knows what industrial engineers do. So that is a drawback, and especially in this region, in Saudi Arabia, you will find that many companies are not aware of what industrial engineers can do, unless there is a industrial engineer from KFUPM who knows what you can do, and then it will be clear. So you always have this identity that you have to establish. Okay, so typically in the job market, for jobs of data science for industrial engineers in Saudi Arabia, you have to show that you can do these skills. So there will be a usual hurdle, initial hurdle that you might hear from many people, and that is because of the misconception that what industrial engineering is, or what industrial and systems engineering is. It is, something broader than people perceive or people think about it. Okay, so this is what I was planning to present. It was a short, talk, and I hope I covered all the topics that I was asked for. But if I missed anything, please let me know. And if you have any questions or doubts or comments, also please let me know.
Thank you, Doctor, very much. Anyone have question, you can raise your hand or write in the chat, no problem. And before that, I will send evaluation. Please fill it.
Okay, so any questions, any comments? Okay, Mahdi has a question. Go ahead, Mahdi. I think we cannot hear. Maybe you can write it in the chat.
Doctor,
Yes, Ammar, go ahead.
I want to ask you if should I be good in coding before I go this, or I will learn inside this consideration about coding and programming.
Well, you don't have to be good at programming before taking this, but you have to simultaneously learn programming, because the instructors might not start from scratch. They will assume that you have some programming skills, and then they'll start from there. So if you are not good at programming in Python, especially in Python programming, then while you start the consultation, simultaneously you learn programming, and it is hardly a matter of 3-4 hours. The basic programming can be learned very quickly with respect to Python. I'm not talking about C or other languages. I'm saying Python is very easy. You can immediately start working on it. Okay.
Okay, thank you, Doctor. And so if ICE 291 is enough, or in the beginning, if you like pass this course and go to this consideration.
Yeah, if you take ISC 291, I think immediately you will be set. You will be completely set for this concentration.
Okay, thank you.
What kind of data that will work with? Actually, this is very general thing. Depends on the instructor. Sometimes the instructors can bring data from their work. For example, I think right now we have one instructor, at least this is what I know, for the ISC course. Okay, for this one we have an instructor from Aramco, so he might be bringing the data from his work experience. Okay, but other than that, there is no such restriction on data for the courses. Okay, so the instructor can get the data typically from the open repositories like UCI machine learning repository, or Kaggle, or other open repositories. All right. Did I answer your question, Mahdi? Abdul Rahman is Oh, so that is, I believe in the course, if there is a project, the instructor might ask you to work on a data that you like. Because from the course itself, there is no, how should I say, there is no specific data or no specific area, except in the last one here. For example, here you have the data coming from security or maybe coming from some contemporary applications. So these applications could involve many things, including power field, medical field. So there is no fixation, there is no specific data type that you'll be working on. But most probably what I believe is, for example, the instructor who's teaching this course might have a project or might give you an assignment, a coding assignment, where he will give you a data or he will ask you to pick the data and do the analysis. Okay. So these courses might involve a project, and if that is the case, you will see, uh, the data. So I think data is not fixed in these courses. And I know for sure in ISC 487 there is a term project. But what about the other courses? Most probably they should have project, because these courses are so general that I think except maybe the first course, which is 405, I believe like all the other courses should have a project. Okay. Let me answer the question from the first one from Abdul Rahman. What is the difference between data science and data analysis? Well, data science is a bigger area. It's like a bigger thing. Data science is everything related to the data. Data analysis is just a small thing, very small, minor thing in data science. Okay. So data science is a bigger area. Data analysis is very small, specific thing, which is just like summary of what has been done in the data. Okay, Abdul Rahman. Okay, now Fahad is asking, does your degree matter in data science? I would say no. This is very important. Data science is an area where you have people from different disciplines working, but it revolves around these three main areas: statistics, math and stats, programming, and optimization. Okay, so if your degree has these different aspects, then it will be very, very useful, and you will be you will find yourself at home in data science. We have a question from Muhammad. Where can we find sources that can improve our knowledge of data science after finishing the concentration? Actually, data science is a thing that is can be improved through experience. Through experience, how much you will learn. You have books and books to learn, but it's always the practice that will show you some of the things that are never taught in the book. Okay, so the best way to master the knowledge of data science is to work on data science typical projects that are available on Kaggle or KD Nuggets, and also participate in the conferences or workshops related to data science, just to know what is the new thing or what is the trend in data science. But it's more of working on projects which are open. And if you go to kaggle.com, you will find lots of open projects, and you'll find also lots of work projects which has solutions. So you can look at them, and from there you will improve your data science skill. Ammar, you still have your hand raised. You have another question?
Yes, Doctor, I have another question. Doctor, I want to ask you how I will get the benefit of this consideration as ISE major, because my major is ISE. So how this will be different for me if I take it rather than the other major that hosted in this consideration.
So you have to think in two directions. what will you, so you have to think, what are you going to do after undergraduate degree? Are you going to go for higher education, or are you going for work? If you are going for higher education, then it depends on the area that you select in your higher education for your master's and PhD. If you want to do something in machine learning or artificial intelligence, then yes, this concentration will be very, very useful for you, because it gives you a strong background, actually strong mathematical, because some of the courses here, ISC 487, this 413 and 405, some of the concepts here, of course here as well, involves some good foundational mathematics for data science. So it will be very helpful for your higher studies. Now, if you think in terms of job, the number of jobs for data science are in this particular framework, time frame, from the last couple of years and so on, you have lots of jobs on data science. Actually, there are more jobs in data science than maybe any other particular application. So you will also find scope in the job if you move to the job after your undergraduate degree. But there is always, for industrial engineer, okay, there is always this thing that your identity is something that you have to establish. People will have different perception. Even now, when I say to somebody that I'm industrial and systems engineer, they will have different thoughts about what industrial engineer mean or what systems engineer mean. So that is something that you have to deal with.